So now we are going to separate our train and test data set. If you remember, in the starting we had clubbed both the data sets so that the changes that we make are applied to both of them. Separating the train and test data set. Okay. So for that we will make one data frame df underscore train. This is equals to df of. So the logic here is that the price value will be null in case of train data set, and in case of test data set the price value will be in case of test data set the price value will be null. In case of train data set price value will not be the null. So df is not df of price. Dot is null. And the test value, the values will be null. This way we can separate the databases that we have concatenated in the beginning. Now let us go with the feature selection. We will have a look at the feature importances. For this we will use extra trees regressor. So feature importance using extra tree regressor. So from sklearn dot model ensemble import extra trees regressor. Let us make an object etr. etr is equals to extra trees regressor instance. Now we will fit our data set into this. Now there is one step that we forgot to do before this. Here we have to separate, now we have to separate this target variable from the features. So to do that, let us see. Separate the target variable from the feature. Basically we want x and y. So for that x will be df dot drop. What do we want to drop? We wish to drop the price. Df dot and which axis? It is the columns. So axis is equal to 1 and y will be df of price. Thus we have x and y. Now when we are fitting this extra trees regressor, now we will pass these variables, these two data frames as the argument. So etr dot fit x comma y. I made a typing error. Has no attribute fir, sorry. Input y contains nan. Okay, see here I made a mistake. I read it as df dot drop. It should be df underscore train dot drop, right? This is the mistake I have done. So when you are making the program, like this only you will learn. Means you will continue it, you will do it, you will make some mistake, the error will be thrown up, and then you will check out the code back, and then you will get it right. It is a feedback loop, feedback mechanism. So let us move ahead with it. df underscore train, there seems to be some issue. I have already executed it, so I should not face this problem. Let me try executing whole code once again. Okay, I am still facing this problem. No issues. Let me check y odds. So if I put y, I am getting NaN values. Okay. See here, df underscore train. This is the mistake that I have done. This is the mistake that I have done here. I had to put it as train. I put test. I put that train both at the both places. Okay, now this error will not be thrown. Now this is done. Now we can check the feature importances that has been allotted by this extra tree regressor. Let us see how that is done. So print best etr dot feature underscore importance. Thus here we have the feature importances that has been assigned to us. Now I want to plot it into a graph format so that I can get a better visualization of this. Here it is not very easy, not means the data is not so useful, doesn't seem so useful. So let us see how we are going to make a plot. Make a plot for feature importance. First we will do plt dot figure. Here fig size equals to 12,8. Whatever size I am comfortable with, that I will use. Now let us do feature underscore importance. This is equals to pd dot series etr this thing. This whole thing we will copy from here, comma index x dot columns. Now we will say for it to plot it. The largest 20 values dot plot. What do I wish to plot? Bar h, horizontal bar graph. And then we will do plt dot show. Pandas has no attribute as series. Again one typing error. Okay, and we have our bar graph. See, so the total stops has the highest feature importance, followed by journey day and airline, whether it is Jet Airways or not. Means it depends upon the airline. Source and destination have a little bit of less feature importance. So we have one visualization, we get one idea. total number of stops has a very huge impact on our model. Okay. Now we will fit this model using into the random forest. Fitting the model using random forest. So, what are the steps that we are going to follow? See, first of all, we will split the data set into train and test. Next, we are going to see, next step is generally to do the scaling, but in this case we are using the random forest. So, random forest does not require scaling. So, in this example, the one that we are demonstrating right now, we will be skipping this step. Third step is we have to import the model, then we have to fit the model, then we have to predict outcomes, and then we have to evaluate the model. So, let us go ahead from here. So, our first step was split into train and test. From sklearn.model selection, import train test split. Now, x underscore train, y underscore train, x underscore train, x underscore test, y underscore train and y underscore test. This is equals to train test split x comma y. We have to pass both our data frames. Test size, we have to specify how much percentage of the data will be the test data frame. We will give it as 20%, so 0.2, and we will give some random state. Random state equals to 42. This will freeze it. I seem to have here put comma instead of dot. Okay, the splitting work is completed. Now I will import the model. Import the model. So, for this we do from sklearn.ensemble import extra trees, import random forest regressor. So, RF equals to random forest regressor. Now, we will fit our data set into it. RF dot fit x underscore train, y underscore train. This will train my model. There seems to be some error. What is the issue? Random underscore. Okay, this underscore should not be there, no? Okay, so we have corrected it. The model has been fitted. Now we will check the score. RF dot score x underscore train So we are getting it as 95% on train data. Let us check this on test data also. Here we are getting an accuracy of 83%. Now let us import some metrics. Basically we will check RMSE score. We want to check the RMSE score. So for that what we are going to do, from sklearn.metrics import mean squared error. Okay, so MSE equal to mean squared error. Okay, mean squared error for what? So I have to find it for test and predicted value. See, I did one mistake here. I have to do prediction also. For evaluation, first I have to do prediction. So y underscore predict equals to rf dot predict x underscore test. So now we have the actual test value and the predicted values. So y underscore predict and y underscore test. We have passed both of them, both the parameters. Now we want the RMSE. So what will be RMSE? This will be np dot sqrt, that is square root of MSE. Now let us ask him to print the RMSE. Print RMSE comma RMSE. So we have an RMSE value of 1895. Up till now we have imported the model. Now after this we will see hyperparameter tuning. We will use randomized search CV for hyperparameter tuning, and then we will save the model.